Hello YouTube, this is Dazza the cameraman. Today is Thursday, February 14th, 2019, and this is a response video to Mr. Thrive and Survive. In his video, Does the Moon Really Rotate? Now Mr. Thrive and Survive and another channel called Teeth of the Lamb have posted some videos recently questioning about whether the moon should or shouldn't be seen rotating or apparently rotating as it crosses the sky. Now, of course, I've actually done videos on this previously. I think my earliest video about this goes back to 2013. It's about field rotation of the moon, which is perfectly normal. Now, Mr. Thrive and Survive and Teeth of the Lamb have requested photos of the moon on the full moon taken over a period of hours. This will be on the 19th of February to check whether the moon actually rotates or appears to rotate at full moon. Now, as I've told Teeth of the Lamb, my prediction is 100% that it will be seen to appear to rotate. And again, this is purely due to what's known as field rotation. Now, in this video, Mr. Thrive and Survive mentions equatorial mount telescopes. Equatorial mount telescopes are designed so that there is actually no field rotation because they have to be aligned with the axis of rotation of the Earth and set to the observer's latitude. And the way that the equatorial mount telescope works, it actually cancels out any apparent rotation of the object that you're looking at. But anyway, this is about the moon, and Mr. Thrive and Survive has posted this video looking at moon calc. But I'm afraid, Mr. Thrive and Survive, that there is one little factor that you have not understood in your video, so I'm going to explain that to you here. So first of all, let's have a look at a section of Mr. Thrive and Survive's video and hear what he has to say.
And the moon will move here, but I want you to pay attention over here to what happens to the moon. And I want you to pay attention to rotation and how much it is rotating. Now, I can't set this on automatic, but I'm going to try to do this as evenly as I can through the screen. And what you're going to notice is the moon rotates faster at first, and as it gets towards moon set, it rotates much less. So let me do that, and I'll come back and talk about it. So I'm going to start at 2 p.m. This is the current 56.5% full. It is the waxing moon, and for February 2019. So here we go. Look at the rotation. I know I'm jumping a little bit, but I'm trying to get as evenly as possible each hour. And now look, the last so many hours, it's hardly moving at all. Now, I was on a hangout with a globe believer and some flat earthers, and a flat earther who thinks that, oh, this is just perspective. Some people, I guess, could call it field rotation. But everybody on both sides agreed, even the flat earth side said, if you can catch this rotating with an equatorial mount, then it is rotating. And so both sides, I think, agree on this. So we are going to try to catch this actually later this week or next weekend on the waning side, because we want to catch the moon when it is full also and catch them both in the same part of the sky, because our theory is that the moon does not rotate when it's full, but does rotate when it is not.
Right, so there you heard a short clip from Mr. Thrive and Survive's video. Now, as I said, with an equatorial mount telescope, there will be no rotation seen because the equatorial mount telescope cancels out the rotation. If you're using a simple tripod or an alt-az, that's altitude azimuth mount telescope, which simply moves up and down, left and right, then you will see apparent rotation. And as I said, I've explained that in my earlier videos, and I'll post a link to the particular video in the description below. But let's have a look at moon calc. I've got the same location and date set that Mr. Thrive and Survive was using, and he started off at around just before 2 p.m. and so let's set that. It was 13:56 I think he had, close enough. And you can see the moon's position over here, and he rightly pointed out that this is a correct depiction of the apparent rotation of the moon in the sky. And as we move this, you can see that it does actually change the apparent rotation. Once again, that is caused by field rotation. But the thing that Mr. Thrive and Survive has overlooked is this line here where it says moon culmination. Okay, now that is basically the same as if you're looking at the sun. When the sun is due south, as seen from the upper latitudes of the northern hemisphere, it would be at solar noon. Well, the same thing applies with the moon. We've got the moon at its highest point in the sky, and that is the moon culmination. That is when you've got most rotation, simply because of the geometry of looking at the moon. So let's do that again, but we'll note the time. It says that moon culmination is at 1855, so that should be when we see the most amount of rotation, as we have to turn on the spot to follow the moon as it crosses the sky. And then after we've passed moon culmination, then we see less apparent rotation, because we're not having to turn as much on the spot to follow the moon as it crosses the sky. So that's something that you need to look into, Mr. Thrive and Survive. You need to understand the geometry of what you're looking at, and hopefully my video showing a Concorde aircraft and some fighter jets flying over, doing a flyover, I think it was in France, leaving coloured trails behind them, smoke trails, will help you understand what you are seeing. Once again, I will reiterate what I told Teeth of the Lamb, that I predict 100% that rotation will be seen at the full moon, unless of course the photos are taken with an equatorial mount, which cancels out the rotation. I also plan to post a video using my Starry Night software, a prediction of what will be seen on the full moon. So I'll post that if I get time. Thank you for watching.